Today I am going to present my topic is an rebound hardness test, which is the type of an dynamic hardness test. We know that the hardness is the resistance of the material to deformation or indentation. Most of the hardness tests like Brinell, Rockwell and Vickers are the static hardness test, but the rebound hardness test is one of the dynamic hardness test. But the rebound hardness test works on the different principle. It measures the hardness based on the impact and rebound energy. Now we seen that the principle of an rebound hardness test. When the weight or a hammer is dropped onto the specimen surface, after the impact, the striker rebounds then upward. That means when the specimen hits the surface, part of the energy is absorbed by the material. The remaining energy makes an bounce back, that is determined as an when the material will be an harder, the energy absorbed is less, then the rebound height will be higher. In case the material will be the softer, the energy absorbed is more and the rebound height is an less. This is a principle of an rebound harness. And next we seen about the working of rebound test. It is the same as the principle of rebound. That means when the specimen absorbs the part of energy and remaining energy causes the rebound. Next, dynamic harness test. It is one of the type of an rebound harness test. When the rebound harness test can be mainly classified into two types. There are dynamic harness test and dynamic elastic harness test. In this dynamic harness test, when the measures the harness under a impact loading conditions is called as a dynamic harness test. That means when the material will be deforms elastically and plastically due to the kinetic energy of indenter. When a harness inferred from rebound or indentation behavior is known as the dynamic harness test. Mainly in this dynamic harness test can be classified into two types. There are an fall harness test and impact harness test. Okay. Next, in a fall harness test, let's see the importance of fall harness test and also what is meant by the fall harness test. When the mass falls freely with the indenter and forms an indentation is known as the fall harness test. That means now see the diagram for an fall harness test. The A is diagram is an fall harness test. In this diagram, I already said that is when the mass freely into the specimen along with the indenter and creates an indentation is known as the fall harness test. In this fall harness test, it is one of the dynamic harness tests in which known as the weight is dropped from a fixed height onto the indenter placed on the specimen surface. The harness is determined from the size of the indentation is produced. And also in the rebound harness test is directly proportional to an rebound height. Next we see about the impact harness test. In this impact harness test, when a hammer or a spring drives indenter into the specimen, is known as the impact harness test. Let's see the diagram for an impact harness test. The B diagram is an impact harness test. In this impact harness test method, the ball rests on the specimen of the surface and triggered by the hammer blow or a spring force is known as the impact harness test. In this impact harness test can be used to store the mechanical energy. In this both are measure the resistance to deformation under an impact. It is known as the dynamic harness test. Next, we see about the example of impact harness test. One of the most famous instrument is an Polti instrument which is used in the impact harness test. And also it is one common instrument. It is working on the Boldy hammer. The indenter is placed between the specimen and the standard test bar as an bolting instrument. Then the hammer blow is applied. The indentation are formed on both like specimen and standard is known as the Polti instrument. And in this Polti instrument, how we will calculate the hardness? In this Polti instrument, we calculate the hardness by and comparing of indentation in and diameters is known as the Polti instruments. These are the two diagrams for a dynamic hardness test. Next, we see about the dynamic elastic hardness. In this dynamic elastic hardness is rebound height or an angle can be measured and it is only applicable for an low deformation materials. Next, hardness is directly proportional to the rebound energy. I will say in earlier when the hardness is directly proportional to the rebound height. I said in the dynamic hardness, but in the dynamic elastic hardness, when the hardness is directly proportional to the rebound energy. In this dynamic hardness have also consisting of two types. There are shore scleroscope harness and equotip method harness. And in a dynamic harness test, we have consisting also two types. There are fall harness and impact harness. We already seen that. Now we seen about the two types of dynamic elastic harness of shore scleroscope and equotip method. Now we seen that the shore scleroscope method. In this method, we use as a drop hammer principle. When the diamond tipped or hardened steel ball can be used as an indenter, and also hammer dropped through the glass tube onto the specimen. The rebound height can be measured by a calibrated scale is known as the source scleroscope. The harness can be reported in an source harness units. That means when the harness can be reported in the unit in the score scleroscope is source harness. Next, the diagram for the shore scleroscope is an A1. In the shore scleroscope, it is the drop of a hammer principle. The indenter is either a rounded diamond point and a steel ball that rests on a drop hammer. This falls through the pipe vertically and through the into the specimen and rebound again up to a particular height. It is measured by the shore scleroscope. And then we explain about the equotip harness tester. In this equotip harness tester is known as an angle of rebound in the dynamic elastic harness test. In this method, we use an carbide ball indenter and also measures the impact and rebound velocities electronically. Next, harness can be calculated from velocity ratio. In this method, we can be calculated from the velocity ratio. On an shore scleroscope, the harness can be reported as an shore harness unit. On the other hand, equotip harness test, harness can be calculated in velocity ratio. Next, portable and suitable for a large components. The equotip harness test can be only suitable for a large components. Fast testing but less precise than the static method. That means static methods are what are the static methods like Brinell, Rockwell, and because of the static method of harness. It is rebound harness is one of the dynamic method harness. So in this dynamic method harness is less precise than the static method harness. Okay. Next, the diagram for an equatip or angle of rebound. The angle of rebound is one of the most important one. That means the angle of rebound is an angle at which the hammer or an indenter rebounds after the striking the material surface. That means the dynamic impact the types test the rebound path forms an angle relative to the vertical. Some energy is absorbed by the deformation. Remaining energy can be aqueous rebounds. It direction of the rebound makes an angle with the vertical is known as angle of rebound. In this angle of rebound, we can be used as the carbide ball in the diameter of 3 mm used as indenter. After the release of the preloaded spring, the indenter is thrust against the test specimen. Next, we see about the applications of rebound hardness test. The rebound hardness test can be used in many applications, particularly the large work pieces where indentation is not desirable. The rebound hardness can be used. Field testing and portable measures can be used by rebound harness. Next, surface harness evolution can be calculated from using a rebound harness test. Then, quick comparative hardness can be measured by an rebound hardness test. Next, finally, we concluding this topic, the dynamic hardness evaluates the material response to an impact. Rebound behavior indicates the hardness. Next, common instruments like shore scleroscope and equatips are one of the common instruments in an dynamic elastic hardness test. And also in a dynamic hardness test, there are the two main instruments, that is then Polti instruments. Next, useful for rapid and non-destructive hardness can be assessment. And then, when a dynamic hardness test measures the resistance of the materials under a sudden impact loading, the shore scleroscope determines the hardness tested on the rebound height or an angle, which depends on the elastic recovery. Although the dynamic elastic hardness test is one of the most famous one, and the rebound hardness test is less precise than the static hardness test, so it can be used for an quick and field applications. These are the conclusion for the rebound hardness test, and thank you for this opportunity.